All right. Applications of polynomials. So just finishing chapter 4 here. So we have a utensil company and we have a benefits cost ratio. And that is our ratio from our revenue over cost. So let's see here. So the revenue equation is this -4 equation, and the cost equation is this 2.3. So here's our task. Prepare a all pertinent information. So again, key points, things like that, multiple representations of this. So this would be graph it in Desmos, look at it, where are constraints, where are we going to make money, where are we going to lose money, all those things. So let's try to pull up Desmos here. So um, all right, so if we're graphing these, right, so let's write these equations out so we can graph these. So we're talking about -4 x to the fourth plus 44x to the third minus 147 x squared plus 162x. That's our revenue. Our cost is then 2.4x to the third minus 10.48 x squared plus 16.67, sorry, 76x plus 13.2. All right, so now let's go here and graph these. Right, so the first one here is -4x to the fourth plus 44x to the third minus 147x squared plus 162x. Right, so here's our revenue, right, function. So you can see this, right? We got a peak here, here, and here, right? So looking at those peaks there is 0.82, right? And then the other big peak was 4.95 for our X values, right? And so what are those, right? If we're looking at that, that's revenue, right? And X would be the number of utensils sold, right? Um, in the hundreds, right? So this would be or 495, so close to like 500 utensils. Um, and this would be like 82 utensils, right? And these are in packs, right? So like you could think like you go to Walmart or somewhere and you buy like a pack of 75 or a pack of 500. Those are going to be our big revenue items, right? Which is money we bring in. Revenue is money brought in. It's not profit, right? And then our benefits cost ratio. So let's go to like cost, right? So if we graph the cost, right? So 2.4 um, x cubed minus 10.48 x squared plus 16.76x plus 13.2. All right, so if we look here, right, this cost function, right, kind of looks like this, right? And it's cubic, right? So the more we make, obviously, the more this cost function is going to go up, right? So then can we do this benefits cost ratio, which is just these two divided, right? So -4x to the fourth plus 44x to the third minus 147x squared plus 162x. Whoops. Okay. Golly. I don't know why this isn't working. Okay. So then let's divide that. Right. So we're going to have to use parentheses here. and then divide, right? So the whole thing. So we'll divide the bottom equation, right? Okay, and then plus 13.2. Okay, so if we look here at our benefits cost ratio, we get this equation, right? And so where is the best, benefit versus the cost, right? So the revenue divided by the cost, right? Our best ratio is at 2.09, which is around 200 utensils sold, right? In packs of 200. And so you could say, well, I'm going to make I'm going to bring more money in if I sell these packs of 82 and 500. But you got to figure out cost, right? And so the best benefits cost is going to be around the 200 pack, right? 209 to be exact, right? And so, but just looking at all this and preparing this for a business is where you would use this polynomial idea in a business. So let's look at the next one here of chair sales, and let's look at the same deal. So we are selling chairs for $145 each, right? And so we're looking for ways to increase that revenue. Okay, so if we give a discount of 10 cents, now that's cents, right? Different deal, per chair order. What would the equation be, right? So that's we're gonna sell chairs for $145, but it's 145 minus 0.10 cents per chair, right? Times the number of chairs sold, right? Okay, so that's what we would get there. So we get that equation, and let's look at this. So when we graph this, what would this look like? So Well, let's wait. Let's just wait to graph it. Okay. So B says, why would they put a limit on the number of chairs ordered in a single order? Well, because eventually, if this gets high enough, my chairs are going to be free, right? Um, so it is known that the cost to fill an order, right, is given by this equation. Answer part B again using this information, right? So um, actually, well, let's figure out what the limit should be. So let's go back here. Now let's figure out the limit on these chairs here. So let's go 145 minus zero point 0.1x times x. And let's see what this graph is. Okay, so we should have a parabolic, right? Pretty big parabolic, right? But let's see here. So 725 is going to be the max profit. That would be a good number for us to make money. But if you look here, once I get to 1,045 chairs, it's going to be free for them. Okay, so we can't sell it for that, right? So I would say this is a good number. Um, but looking here at this, right? So now we have cost. So this is the money brought in. Now let's look at cost, right? So revenue minus cost tells us profit, right? So let's do that. So let's go minus, right? Let's go minus parentheses that point two. What is it? 0.2x times x plus 200. So 0.2x times x plus 200, right? And let's look at that, right? So now we're at 175 chairs, right? And we start losing money. We start losing money at 350 chairs. So in this one, we just because of the cost that it makes to make a chair, we're losing money after 350 chairs. So that's our cap. And we're really looking at 175 chairs being a good number to sell people. Okay. D then says, what's the benefits cost ratio? And they want to make sure it's at least 200%. So benefits cost is just those two divided, right? So our revenue divided by the cost. So that would go back to this 145 minus zero point 0.1x times x. and then that would be divided by, right, that 0.2x times, what was it, x plus 200? Yes, x plus 200, right? And so there's our benefits costs ratio analysis, right? And we want that to at least be 200%. Okay. Again, there, 200%, that's 130 chairs, right? That Y value of 2 is what we're looking for. So that's 130 chairs there to get that Y value of 2. Okay. So that's just some idea of like business economics and how these polynomials are used in the business world. So really cool lesson there, especially when you dive into, how this is used. Yeah, in business and business economics.